This video demonstrates how AppDynamics, in partnership with Rookout, takes root cause analysis to the next level and helps further reduce time to resolve business-impacting issues. The flow map here shows the topology of a loan processing application. It's comprised of a number of components and queues. It lets people sign in and submit applications for loans. Various checks are performed, and the loan application is either approved or denied. Based on the health scorecard at the top right of the screen, we're having issues. AppDynamics looks at business performance of the application at the very granular level. In this case, it separately tracks execution of each step of the flow: login, application submission, credit check, and underwriting. We call them business transactions. Looks like our users are experiencing problems with loan application submissions and credit checks. When there is an impact on performance, AppDynamics collects more data about transactions, a transaction snapshot. Let's try to understand what's going on with the application submissions by first inspecting the snapshots. The most recent was triggered by an error and has a call stack. Let's drill into it. Apparently, the submission was interrupted by an exception. The exception does not give us enough information about the root cause, other than that a null pointer is sneaking in somewhere in this function. We could simply pass this information along to the application development team, but it may not be sufficient for them to find the fix. What if the problem is data-related? It's quite common that the pre-production environments do not have access to the production data, and developers may not be able to reproduce the issue. To shortcut the back and forth and to get closer to the root cause, we will do a deeper analysis. From a call graph, we will initiate a live debugging session. It will take us to the up-to-date production code that executes this business transaction. In this view, we can set virtual breakpoints to better understand why the exception is happening. Debugging in production may sound scary, but our breakpoints will not interrupt the execution of the program. The virtual breakpoints are set just like in any IDE. Click on the line where you want it. When it's ready, it turns green. The breakpoint collects all the information that one would expect in a traditional debugging session: local and class variables, call stack, etc., with no performance impact. We start with setting a breakpoint in the catch block where the exception is most likely trapped. When it is hit, the collected information is displayed in the messages panel below. And here is our null pointer exception. Let's put additional breakpoints to identify the line where exception occurs. Once we've accumulated enough data, we can pause the logging of breakpoint information and analyze what we've got. Only one breakpoint on line 90 is triggered before the exception. Line 91 and 98 are skipped. From here, we can deduce that the exception occurs when the program attempts to use an external service versus a local queue, and that the connection with the external service cannot be established. As a result, it is the connection object that must be null. From here, we can investigate why the external service cannot be contacted. In addition, we can share the debugging information with the developers, along with very specific feedback that a check for a valid connection may be a good idea. Live debugging can be safely used at any time from the call graph of business transaction snapshots, and not just when looking for a root cause of issues. A live debugging session can help quickly build data collectors to augment business transaction analytics. For example, now that we know the method names and associated parameters, we can collect non-sensitive loan application data at each step of the loan approval flow. The data can then be used to build a conversion funnel like this one and track application performance from the business point of view.